In this hands-on lecture, I will discuss about the most used among the most basic topic modeling techniques called LDA, which stands for latent directed allocation. Let's create a Java file called LDA main.java and insert it in our test.main package. For you, I already create LDA main.java and it should look like this. Same as before, we're going to use New York Times news articles. So we use scanner object and read in the news articles. In this case, we're going to stop once we read in 1,000 news articles from this file. And then after that, we close the scanner object and we create LDA. So let me explain this function more detail. Create LDA takes two arguments. The first one is number of topics. And the second one is number of iteration. Let's go into the function. The first one is number of topics, as I said. The second one is number of iterations. In reality, number of iterations between 1,000 to 2,000 it produced most best performance. For this demonstration, I only have 100 iterations because of the performance. If you have a bigger number of iterations, and that means it's slower. And if you have a smaller number of iterations, it's faster. For demonstration, I'm going to only show you the outcomes very reasonably fast. After you create LDA, then majority of the logics coded into this create LDA function. After that, what we're going to do is we're going to see what kind of topics are generated, what kind of words, top words are generated. So let's take a look at this create LDA, which is a core function of this LDA implementation. If you recall the lecture notes for LDA, we instantiate pipe, which is character sequence lowercase, character sequence to token sequence. Third one is token sequence remove stubbers. Fourth one is token sequence to feature sequence. So this is a series of pipes. There is a dependency between pipes, so you cannot call or instantiate token sequence to feature sequence before you instantiate character sequence to lowercase. So character sequence to lowercase is you basically take the input and tokenize and make it lowercase. And then once you have character sequence, you make token out of it by taking this one argument. The one argument is pattern, so regular expression. After that, if you want to remove stubbers from the tokenized words, then you simply instantiate token sequence to remove stubbers. This is optional. If you don't want to remove stubbers, then you just simply comment out this pipe. Once you create pipes, then you instantiate instance list object by passing the list of series of pipes. And then you loop through the documents by using iterator. And then after that, you're ready to execute LDA. As I explained it in the lecture note, Marlot implements multi-threaded LDA. It's called parallel topic model. So here you set alpha and beta and number of topics, and you add instance list to parallel topic model. Then you can also set the number of threads. So number of threads now is set to 2, but you can bump it to 5, 10, or 20, depending on the availability of your computer resource powers. And then you also set the number of iterations. So the number of iterations, as I told you before, between 1,000 and 2,000 is ideal. After that, what you do is you call estimate function. The estimate functions takes care of inference algorithm of LDA. After this step is done, basically what you're going to do is you're going to save the topic model, and also you save instances. Why are you doing this? Is just because you want to, I mean, if you have a huge amount of text data, then processing and creating instance lists and generating topic model takes time. So you don't want to generate topic models every time you execute the LDA. So what you may want to do is you save, you train and save the topic model, LDA topic model, and also instance list. You can save one of those two, or you can save both. After that, we create this topics, and topics is basically if you set 10 topics, then we have the number of topics 10, and we have 10 topics. Per each topic, we have n number of words. Well, here, if you want to print out the result of topic models, and then what you can do is you simply instantiate the file, and then location of the file, in this case, LDA_out.txt, under your project, which is y-TextMiner, and you call LDA's print top words function. It takes 3 arguments. One is the output file, second is number of top words, and third one is whether you want to print out the new line or not. If you want to print every single word belonging to that particular topic, then you will uncomment this part, print topic word weight. It prints everything. But if you only want to see top n number of words, then you may want to use the second one. All right. Now let's go back to LDA main.java and simply just call this. Remember, I only have 100, but you need to make it to like 1,500 or so. And also, the number of topics will solely depending on the data that you have, the number of documents you have, and you may want to use several number of topics, and then set the final one, whatever the final topic numbers resulting best result, you will probably use that topic number. So let's execute LDA main.java. So the red font debugging message is all coming from Marlot LDA. It prints out the initial result of 10 topics and its probabilistic value for each topic and top words that belonging to that topic. So right now it prints topic 0 to 9, which is 10 topics. Very fast, because we only have we have only 1,000 documents with 100 iteration. So see, this is each topic number and top words depending on the data that we have. In our case, we use New York Times news articles. So first topic consists of company, city, York, according, former, deal, Volkswagen, and so on and so forth. What we may want to do is here, we may want to eliminate numeric value. What you can do is you can put this numeric values in star word list, or we can adjust pattern regular expressions so that only letters, we keep only letters. There are several ways you can do, so I suggest 2 of them here. So we have 10 topics result printed.